Welcome everyone, students, parents and teachers. Today is an exciting day for us here at Klaritree to bring a new series called Klaritree Talks. Today we'll be having our webinar on the topic of mind maps and how to apply them to every school subject. Without further ado, I would like to introduce Professor Mahadevaiah, an award-winning author and content creator. I hand over the webinar to Professor.
Thank you, Prajwal. I know that students, teachers, as well as parents will be eagerly waiting for this webinar to happen. It all started 25 years back because this topic about the mind map. So I got to know through a book written by Tony Buzan. Now he is no more, but in 70s he conceived this idea and then started researching about the topic. Why the way we learn, what we learn is very linear and what we take as notes will be linear, and it will never be natural to human mind. So then how to utilize the power of the human brain? That was his thinking during that period. And then he came out with an idea called mind map. Until then, there was no word like mind map. So then he started spearheading this mind map technology, and then he has spearheaded until recently so that everyone can benefit out of this mind map. He has also written another book called The Power of the Mind. So probably this mind map technique will be so useful only when you used to it. You will understand that this is such a huge knowledge about learning. It is not just a school subject that we can learn. We can learn anything and everything. Then who can learn? Everybody can learn, whoever know how to write and understand, because it's such a, you know that human brain is always not actually textual, it is pictorial, because even in during the cave dwelling persons, they used to talk about, they never used to tell something in terms of words, but always they used to tell in terms of graphics. So graphic is 1000 words worth. So that means that is the capacity of the graphics. So it is, what do you mean by mind map? So let us start understanding. You know that the potential of the mind can always be explored because there is a left brain and right brain. So normally a person with a left brain will be very powerful in logical thinking and then mathematics kind of stuff, and the right brain always will be artistic and then probably the creative kind of personality. But these two will never combine together. But how to make use of that? Because we have to use the full potential of the brain. Then you need to understand, and mind map is the best way to incorporate in such a way that both will be utilized equally. So let us understand the mind maps techniques. So there are a lot of course, benefits. Discover how mind map can revolutionize your learning. We will explore that. Then the subject specific, what subject you can actually mind map. You can mind map any subject, not just the school subject. It can be any topic in which you are interested. Then can we become more creative and problem solving? Yes, of course. How to apply creative problem solving, critical thinking, all such requirements of the modern era, so can be easily incorporated into mind maps. Not only just these things, you can actually grasp the complex subjects or any complex concept with ease. You will become so innovative, you will wonder, am I the same person before using mind maps and after using the mind map? So that you can actually think on your own and then get to know that how much you have improved. And this is the very, very powerful technique. I do not know why the schools and colleges are not using, but now corporate are heavily, it is being used. But I request you, just use a pen or pencil along with a sheet of paper or a notebook. That will be the best way to learn mind mapping, because whatever you write, you know that in examination you write all the answers for the questions asked, but there will be a connection between your writing on the paper as well as the brain, the way it functions, it remembers everything. So I always suggest that you initially practice, or always practice, first to sketch or write on the paper, put down your thoughts on the paper, then you can actually refine it, and then probably delete some of the portion, incorporate some of the new things, because the brain will be very, very refreshing after looking at the mind maps. And it's very natural, it's very analog in nature to adopt this kind of mind mapping, because it is built on a technology or a mechanism the way human brain works. With this introduction, I would like to start without further delaying the webinar, because it's very short time what we have, but still able to connect lot of things. So the first one is discover how mind map can revolutionize learning. You know that always there will be central idea. What is that central idea? It can be anything. For example, you want to buy something from the market, you want to achieve something in year 2024, you want to plan it, or you want to study a subject which is hard for you, probably science or maths, or even social studies, geography, history, or even you want to analyze probably the Lok Sabha elections which went through few weeks back. Like that, any topic, it can be sports, it can be your own creative idea, or you want to do a project, everything can be your central idea. And then comes the keywords, you list out the keywords which may become the main branches, like 1, 2, 3, what you are looking at. And again, these branches, again think of the words which can be taken out from this main branch as sub branches. That can be always keywords. Initially you may not find the keywords, but it can be a statement or a sentence like that. You can keep attaching that, and the tree will grow like that. At every node, what we say, the keyword are the nodes. At every node, other than the central node, which is the central idea, you can actually add a picture, image, you can add color, you can add text relevant to that, or even icons. So, or you can put a comment. For an analysis, you can put check boxes, options like that. So many benefits will be there. Manually, when you do it, it will be so wonderful. So this is just a scenario of the mind map. On the left hand side, what is there with the central idea, and then branches 1, 2, 3, 4. And you can see main branch 1 is just at pointing to 1 o'clock in a clock. If you consider a clock, so 1 o'clock is the starting point, and it will go clockwise direction and until 12. So that's the idea. Always you should start with 1 and then move to 2, 3, 4, 5, 6, depending upon number of branches. So it emanates from the central idea. So you can just look at the main branch are always of the same color, you can figure out. So you can see all the main branches are different colors, and it should keep spreading over that. So you can actually keep track of all these the branches, sub-branches, and then the items on that. So this is the fundamental idea behind mind map. Somebody may ask, but what is the definition, sir? Because okay, it's a pictorial representation. What is that we see? So it's a graphical or a pictorial representation of your thought process that's happening in your mind or anybody's mind who is interested in drawing the mind map. So his own thoughts will be represented on a 2D paper. So if you look at any mind map, if it is very vast and very focused, then you can see the person is having a broad knowledge and also the very key insights. He is having very key insights into every keyword. So that's the kind of analogy you can or consideration you can make. So it's just how a mind map can be defined. A mind map is a graphical representation of a thought process of a human being on a given topic or a focused topic. That can be real, that can be imaginary, because an idea is always imaginary before it comes to existence in the real world. So that's why it can be anything which you focus or somebody focuses and then tries to draw a mind map on that. So that's a graphical representation. So that's the idea. Of course, it's a visual representation of the thought process, that's all. So people don't give that. So I am giving, because of my experience, this definition. So what are the benefits? You will be wondering yourself, just use the mind map, start using the mind map. I request all the students, especially teachers, because it becomes so easy for them. You don't need to prepare anything. You just create your own mind map. And one more thing I would like to point out, everybody's mind map will be different. You know why? Because everybody is unique in nature. Everybody's thought process is unique in their approach. So that's why mind map cannot be similar. But if you are working on number of chapter in a textbook or a subject, that can be similar to some extent. But again, the insights into those subjects can be different because the way human beings think different. So every student can have their own. So there is no need to maintain the neatness of the drawing. It can be very shabby, it can be very neat. If it is looking nice, it's wonderful. But try to draw as much neatly as possible. But it is not necessary. So it improves your memory retention. And I will show you at the end of this webinar how it can actually improve your memory. I will often question about the mind map I do here. Then you will be able to focus and understand and then recall so easily, because it works the way your brain works. So this makes learning very interactive and fun, and lot of other benefits. So I am not going to list all these things over here, but let us move on. Then as a student, you have to use your mind map. I mean, technique of the mind map, the mechanism of the mind map, to understand your own subjects, whatever the subject. You can plan your study for that. It can be science, maths, geography, history, or any other topic. Even you can plan your study every day, or you can plan your timetable, tackle exams, review whether you have passed your exam successfully, scored very good marks, and able to crack the exam fantastically, or if there is a failure, not scoring as marks what you wanted, or not able to understand a particular question. So there may be a different levels of failure. Even a subject may be failed. So for every kind of perspectives, this mind map helps you. That's why I request all the students and teachers, even parents, buying things from the market can be mind mapped. So start applying this mind map instead of taking linear notes. Even I will show you how 50, 60 pages or even 100 pages notebook or the content can be easily mind mapped in a single page. You don't need to carry a heavy book in a for the examination. You can carry just a A4 size sheet of paper and just look at the mind map and everything comes alive for your mind, and you can start writing without any problem, and the fluency will be so ease. It is unbelievable, because I have experienced this, especially this presentation, so I am not actually having anything. It contains just a mind map. So why I am presenting this? The presentation should be very flexible. It should be always follow a path. Everything can happen, and instantaneously I can get idea to put forth in front of you. So anything and everything can be done with the mind map. That's the idea behind mind map. So start mind mapping. Don't waste your time in creating a linear notes, because how many times you read your linear notes, you never recall in the same order. But just use the mind map. The trick will do fantastic for you. And I guarantee you that your examination will not be examination. It will be a pleasure for you. There won't be any pressure after you start applying your mind map in learning, recalling, and answering anything and everything. So problem solving. So I said problems also can be solved using mind maps. You can be creative, you can be innovative. Even in industry they use probably Google, Microsoft kind of companies. They already using these mind maps. There are a lot of problem solving techniques like computational thinking and design thinking. There may be others, but these are very two popular problem solving skills or techniques. So in computational thinking, you need to understand what is the problem, the definition, because if you define problem correctly, then it is almost 50% done, and the rest of the thing can be taken up later. If you do not know how to define a problem correctly, then you may end up with not getting what you want. Then the very first thing is decomposition. You know that if there is a big task to be done, it should be divided into several small tasks. Like, for example, you want to conduct a program at your home, or probably a school day at your institution, or any other event. So then this event may consist of lot of things to be done. So you can segregate into the stage preparing, or inviting the guest, arranging the chairs, and then bringing the bouquet of flowers, or probably listing out the guest and then contacting them and inviting them. Then there will be a food a department, like that. So many things will be there. Every team can be allocated with the different kinds of these groups or the tasks. So that means decomposition becomes very, very easy. That's how industry also follows, decomposing any problem. Even if you look at any chapter in a subject, subjects are divided into chapters are divided into topics, and topics are further divided into probably the keywords or the paragraphs, etc., like that. So why? Because it is easy to tackle from the ground up. So that's the idea. So decomposition is the first step. Then abstraction. What is abstraction? Just focusing on what you want. Don't worry about the other things, so because it distracts away your mind. So that's why abstraction is the way to focus. That's all. So pattern recognition. If there are similar things, then you can group them together. Suppose buying an item for everyone and only one person is going, let them make a list of things to buy for each and every one, and then buy from anything, anywhere. So like that, it's a pattern. Okay. So these patterns will help you in concise way of dealing with any project or any problem. Then algorithm development. This algorithm maybe is a computational word, but in a layman's word, algorithm is simply a solution to a given problem. But always when there is a problem, there will be lots of different kinds of solutions for any given problem. And every solution can be an algorithm. And you have to get an optimal solution. And that's what we say the best algorithm which works out in a current scenario. And then of course you have to test run and then refine. So these things always should be repeated, and you go back, you redefine, and then again relook to step number 2, 3, 4, and then test and run. That's how the computational thinking works. And we will take up a problem of how to buy a computer from the market. For this, how big it is, even though we do not know much about the computer, still how to figure out. I will show you so many concepts and keywords will come into picture, and then how different perspectives can be there at every node. It always comes with the practice. I hope you will practice, and today should be the day for all of you to start a new venture, is mind mapping. Okay, so let us switch over to hands-on. I will solve first maths problem and then a geography problem, and then mind map about computers. If I draw the number 1 and 2 with manually using the iPad, and you can also draw simultaneously. You can also add anything what you want, but it need not always similar to what mind map I am creating, but to some extent it will be matching definitely. And then mind map about computers, I will try to do it fast, but if time is not available, then I will switch over to a tool where I can do it fast, and you just keep drawing parallel along with me. Parallelly you can start. So I hope if you are this content is very interesting. What I do is please, you can put your words in the chat box, and if you are in group, please inform that we are in a group and how many students are participating, because it gives us an immense pleasure to have you, all of you over here. So let us start dealing with hands-on session about the maths. We deal with a geometrical topic called shapes. So what is that central idea? The central idea is, so geometrical, so there may be some delay in what you see. Geometrical shapes. So you put some cloud around it, and you can also use color. If you have sketch pens, you can actually use different color for a central, and you can shade the background. All such things can be done. Anyway, instead of this, for example, if you want to put some oval kind of thing, you can always put like that, or you want to put a square around that, that is also possible. So this is how we can actually draw. So geometrical shapes, what is this? This is the central idea. We want to know more about the geometrical shapes. What is the first geometrical entity what we know? It is nothing but a point. Okay. So what I do is, I will start with the 1 o'clock, and that should be a different color. Okay. Use different color. So this can be, so you can draw a path, an arrow pointing towards that. So what I do is, I will put as a point. So you know that how a point physically is indicated by a dot, and this dot will have a name called, say, P or A, B, C, whatever it is. So it's always will be having a name. What is that? So there are two important things. One is, point is always having a name. So that is indicated by a capitalized letters normally. A capital letter. Capital letter. So from A to Z, it can be anything. And then there will be a point is always located with respect to a reference, probably XYZ, or if it is Earth, then there will be latitude, longitude, equator, something, some physical reference like that. So this location as a student point of view can be XY, or it can be XYZ if it is 3D. If you consider XY, it is 2D. if you consider a point in space, it can be considered as 3D, including z or z, whatever it is. This is about point. I hope you have understood point. How do you define a point? It's a geometrical entity which is having no dimension but have name and its location. It has name and location. So location is always indicated by 3 coordinate references, that is x, y, z. Okay. So next, what is the next geometrical entity? What we do is we will take up another color and then figure out that is nothing but a line. What is that? It's a line. So when you say line, it's always a straight line. It can be any line, horizontal or vertical or horizontal, whatever it is. So it can be horizontal or it can be vertical or it can be inclined at any angle. But if you look at any line, it's always between two endpoints. A line or a straight line can be defined as the shortest distance between any 2 points. And always it will have a distance, that d. That's very important. It's one dimension. So we say it is one dimension, 1D. So this is 0D. What is that? It is 0D. Point is 0D. No dimensions. So I hope you have understood a line. It's the shortest distance between any 2 points, or it's a linear path by a point moving along a straight path. Actually, it's a path or the locus traced by a point moving along linearly or linear path. Then comes very interesting point. Probably these two they might have dealt in some other level, but what I consider is the 6th standard mathematics book, whether it is English or Kannada medium or whatever the medium. So we consider a 2D. Now 2D becomes very, very vital because we deal with lot of 2D shapes. So 2D. This is one node. What is 2 dimension? So length and breadth. It's an area surrounded by this length and breadth. What are the geometrical shapes? So normally we say 2 dimension, it's polygons. Right from triangle. So of course these are all regular polygons. What is that? Regular polygons. There will be irregular area. Okay, let us not worry about the irregular area. So what we have is regular polygons. So let me resize this because okay. So regular polygons. What are these regular polygons? We will see. Number one is triangle. You can actually use these pictures or icons in your own fashion. That's very, very important. And then comes probably, you know that you have rightly figured out it's a square. Okay. And then I am not writing any name, or you can add all those names. And then probably the third one will be a rectangle. This can be A, this can be your base, and then there can be a height. This can be length of the side and width or width of the rectangle. These are the parameters. So to construct any triangle you need base and height, or even if you know the angle, there are different methodology. I am not focusing on that because that is the practical aspect over there. And then how to construct a square, you should know the angle because always the interior angle will be 90 degree, and you should know the side of the square, what you need to construct. So then for constructing the rectangle you need to have the length as well as breadth. Okay, so that's the idea. Along with that, it can be a parallelogram. If you know the geometrical property, you can easily construct, and then it can be a trapezium. Okay, so this can be A, and this parallel sides are always named as A and B, and there will be a height. Very similar to that, there can be a circle with a radius R, or there can be different polygons like pentagon, hexagon, etc., etc. So if you look at, I think these things are sufficient. So let us look into that. You should know how to construct a, first you should have this, you should know how to construct this, and then what are the parameters. You need to have the base and the height. If it is an equilateral triangle, there are three types of triangles. You can say equilateral triangle, isosceles triangle. So that also you can indicate types. What are the three different kinds? So one is equilateral, and then isosceles, and then scalene triangle. So in the equilateral triangle, all sides will be equal, and in isosceles only two sides are equal, and in a scalene triangle no side is equal. So this is the kind of understanding that you are going to have. Then square, you need to know how to construct. The angle between each adjacent side will be 90 degree, and if you have the side, then you can easily construct. Very similar to that, you can construct the remaining. And in a parallelogram, you need to know what is the angle the inclined line will be having. Based on that, you can construct a parallelogram. Similarly, trapezium. Then we can find out the area for every polygon. You can add. So what is that area? What is the area? You can find out. And then what is the perimeter of this? What is that? Perimeter of this. So like that, every polygon will have an area. There is a formula attached to that. For example, area of a triangle will be half into B into H, or 0.5 into base into height. Then for a square, it is A into A, or A square. For rectangle, it is L into B. So this will be your area. And then perimeter will be 2 into L plus B. That is, there are 2 L's and 2 B's. So 2 into L plus B will be the area for rectangle. Like that, for a parallelogram, it will be the base and the height, whatever the height, base into height, will be a simple. And for a trapezium, so it can be half into sum of the two sides multiplied by the height. So always the unit of measurement always you can consider, and of course perimeter will be sum of all the sides that make up the polygon, like that. So you can go on exploring these things, how to construct. So your mind will be always pervasive of these things. It will be very interesting to know that your own mind, how it works innovatively once you start utilizing this mind map technique. So let me reduce this. You can always redraw, refine your mind map in a new context. There is no problem. And here itself you can take some other color, and then if you are done with a particular chapter, then what you can do is you can put a checkbox over here whether you have completed understanding this, etc. So and use the color to tick. Okay, suppose if you tick using green, then you are done. So suppose if you are not able to understand, you can actually cross over like this. So you can have your own data analysis over there in the mind map itself. So it will be wonderful to see you. Just look at the mind map and you know what to study and what not to study and what you are confident. All such things will come to your mind instantaneously. That's the beauty of the geometrical, the mind map. So here we are dealing with the geometrical shapes. So let us try to deal with the other part under the shapes, geometrical shapes for the 6th standard, which will be 3D in nature. So 3D, what is 3 dimension? There will be 3 dimensions along with x, y, z axis. It can be length, it can be width, and it can be height. So just like to give an idea, so for example, you know the fundamental 3D figure that is a standard primitive solid is nothing but a cube, correct? Sometimes they call it as cuboid when they vary in dimension. If all the sides are equal, for example, if A is the side, every side, so then this volume is always A into A into A, or so A cube. Okay, the surface area will be, one of the face is A square. There are 6 surfaces, so surface area, total surface area TSA, normally 6 into A square. So it's very easy to remember all these things. So this is about cube. Then what are the other things? I will give you a wonderful idea about 3 dimension. Suppose if this varies in any dimension, for example, it can be a square on the side surface, but the length will be varying. So B and H are equal, but L is not equal to B and H. Then this can be called as the cuboid. Whatever it vary, one of the thing will not be similar, or all other thing can be dissimilar. Okay, so like that, or L and B, L is not equal to B, B is not equal to H. That can be the kind of cuboid. So we say it is cuboid. Even if it is L is equal to B is equal to H, normally it is indicated as a cube, not cuboid. Okay, anyway. So there is another perspective I will teach you today. There are different kinds of polyhedrons. Okay, so under polyhedrons, of course, based on number of polygons that make up actually surfaces, you know that cuboid is one of the polyhedra which is having 6 similar surfaces. Like that, there can be icosahedron, octahedron, like that. So many different kinds of hedrons family will come into picture. But for as a school student, you will have what are called as prisms as well as pyramids, and there will be what are called as solids of revolutions. Solids of revolution. What are prisms? So these prisms will be having 2 polygons, similar polygons separated by a distance. So you join all corresponding corners or vertices to the corresponding bottom. There will be what is called as the top surface and the bottom surface. I hope you are able to clearly this. Then there will be an axis which is imaginary. So O1. This can be A1, B1, C1, D1. Normally it is written as capital. Okay, we'll write this as A, B, C, D, and here also you can make it as actual points always will be capital in letters. Bottom surfaces are always 1 to 1, A1, B1, C1, like that. Top surface are always A, B, C, D. So if you look at, this is one of the prism, and suppose if you replace, instead of square, if you replace it by what is called as a pentagon, then join corresponding corners, then it will become pentagonal prism. If it is replaced by hexagon, it is called as hexagonal prism. If it is replaced by rectangle, then it's a rectangular prism, like that. So that means it's very easy. You know that all the lateral top and bottom surface are similar polygons, and in a prism, and then all the lateral surfaces always seems to be rectangle. You can see here the longer edge is the one which joins the one corner to the other corner between the bottom and top surface, and the shorter edge is that make up the polygons. So this is how the parameters or the properties of any 3D solid can be explored. Then the other kind of 3D will be what is called as pyramid. What is this pyramid? Pyramid, you just have your bottom surface, and the top surface, if it is there, you please remove that or merge that into a point. What is that? An apex. This is called as the apex. And now you join all the base points to that. If the base points are A, B, C, D of a square, and then the top point is O, then OA, OB, OC are called as the slant edge, and this is the base edge, and O1 and O is the axis of imaginary. So if you look at all the side surfaces or lateral surfaces are triangle in nature. This becomes very interesting to get to know this, of course. So the name of the pyramid is always considered as whatever the shape of the base, that is a square pyramid or a pentagonal pyramid or a hexagonal pyramid, like that. So everything boils down to its base here. Then there is one more very interesting. If you consider, for example, a rectangle and then fix on one of the edge, and then if it is a cardboard and if you rotate it about this axis XX, then the resulting figure will be a cylinder. Similarly, if there is a semicircle and if you fix it about the diameter and rotate, then what you get is a sphere. This is a cylinder. And similarly, if you take a right angle triangle and fix it over the vertical edge and rotate it, you will get what is called as a cone. Similarly, if it is a quarter of a circle and then rotate it about one of its radius, then what you get is a dome. This is actually dish. Okay. So dome will be in the reverse order. So if you do it in the reverse order, this is called as the dome. So how your mind will actually go on understanding this concept, the complex concept of geometrical shapes, and you can figure out, and you can also find out the surface area and the volume for everything. So and note down the formula, and you can figure out from anywhere else. You can Google it out, you can ask your teacher to know about that. And with one page of this mind map, so you can study 60 to 70 or even 80 or even 100 pages and bring it down to a single sheet. That's the power of the mind mapping. So just what I do is how maps can be created. So I will move on to another interesting topic from the maps from geometry. So let us see how to create a mind map for that. So you can create the way you want. So normally there will be what is the definition of the map, and what are the types of the map, and what are the utilities of the map, and then how to create mind maps, where they are being used, and probably person who creates maps is called as the cartographer, you know that. So like that, can you make out a profession or a career out of this? So that is very important, profession or a career out of this. So there can be different kinds of perspectives for this. So I will give you a brief hint about how you can actually apply the mind map technique for understanding the maps. So let us focus on definition is nothing but what is a map. So if you know, you can actually put your definition into the chat box. So maps are a representation of what is available on the Earth's surface for a person's perspective. A person can be historian, a person can be a geologist, a person can be a politician, a person can be a single layman, a person can be a scientist, a person can be a medical scientist. Okay. So please, you can put your questions over there in the chat box so that I will try to answer at the end. So the geographical maps can be like that. Different perspective, different maps. Suppose all the resources, water resources available in America is always possessed by the white people, not the black people. This is in a TED talk. I was able to catch up that context. So it is really astonishing to get to know that all the water resources are available only with the white people. That means there is a hidden racism in America. If you say like that, all the resources are available only with the people, you know that the mafia, water mafia, the tanker mafia, like that. Even in India, it's happening. The tanker mafia will have every resources of water. So people, other people, common people will struggle. So then you can go on contextualizing the geographical map. I will simply put some of the things like, for example, if you consider types of the maps, for example, what I do is it can be a physical map. That means all the natural things that are available on the earth's surface, like it can be mountains, it can be rivers, so it can be forest. You can put the figure there. So, or it can be deserts. It can be deserts. You can use different color. I am not, because of the time, I am not using different color. There is no issue with that. So like that, or it can be simply plains, like this. So this can be a physical map. You can also contextualize with your own interest. Then comes the political map. It can be a political map. What is that political map? So people, and always these consist of cities, villages. You can actually put icons to these things, and then probably the capitals, all these things with a boundary. What is that? There will be a boundary, because you cannot, you know that Karnataka is defined by its own boundary. Similarly, Andhra Pradesh, Tamil Nadu, like that. Every state is defined by, and always there will be a quarrel between these. I mean, boundary, this belongs to us, this area belongs to us, like that. So these are the political mind map. There can be a thematic map. So that means based on the theme, thematic map. So what is that? This can be, for example, a thermal engineer's perspective, or probably it can be the rain that is happening in a country. That can also show, or the weather conditions of the, or war happened between two countries. That can be a map where all the zones where war happened, like that. These are all thematic. So this also can be done. And there are very interesting components. So those components are important to get to know. So what are the components of a map? Map components. These are very important. I am not, neatly, tidily writing that, but let me, all of you have that idea of creating it, but that can be rearranged. There is no issue with that. You can be erased, it can be redrawn. So what are those things? The distance always will have as a distance, and the direction, of course, direction from one place to another place, like A to B, and the distance, whether it is in terms of kilometers or meters, like that. And of course the what is that, cardinal directions. That means always with respect to north and the south, and then east and west. So, or sometimes it can be southeast and southwest, and then northeast and northwest, like that. So these are important components of a map, and always it will involve what is called as a scale. Okay, what is the scale? On a map, if you measure 5 centimeter, whether it is representing 500 meter or 500 kilometer, that is the scale. If it is a small scale map, that means it is called as if you are measuring 5 centimeter and then understanding that it is 500 kilometer, it is called as a small scale map. That means the reduction factor will be more. Okay, that is actually the reference factor. So this is very important. Like this, you can actually create these maps for, I mean, geographically with geographical perspective, and you can use the geometrical symbols over here. Triangle can indicate something, square can indicate something, rectangle can indicate something, or hexagon can be something, or a circle with a dot can be something. So all these can be incorporated, which we actually learnt in mathematics shapes. So these can be interlinked. So this is how actually we can interrelate the two different topics. So in a multidisciplinary environment, and your understanding will be totally different level. Okay. So I think we will stop over here about the manual creation of the maps of geography and as well as maths. So we move on to mind map about buying the computers. So that means it can be a problem for you. How to solve that? How to understand the complex scenario using mind maps? We will switch over to that. So I think you can start putting your questions. Be interactive. That's very, very important. I think we will go for a few more minutes because I want to just show it to you how the digital tools can also be used. I suggest you not to use in this level if you are an early learner of mind maps. Become very proficient in that. Then only you I hope all of you are enjoying this session on mind maps, and I suggest you to start using this particular mind map technique and before you buy a computer. So how to analyze what you want to buy? Let us we are not worried about the laptop computer. Suppose you want to buy a desktop computer, digital desktop computer. Okay, so that is one node. Okay, one keyword, desktop computer. Then comes what the kind of desktops available. It can be a branded or it can be assembled. Correct? Of course, if you are not having any money, you can get it from someone else. Okay, so let us look into let us not worry about this. Even branded, you know that there are a lot of makers, like it can be Dell company, it can be HP company, it can be any other company. Okay, so these are the two popular branded sellers. If you want to be an assembled, have an assembled computer, then lot of things. Why I have taken this? Because this is very, very interesting topic. This assembled will give you the entire picture of the kind of system you are going to buy. What are all the things you want to buy? Okay, so first one is let us say input device, keyboard and mouse. Again, you can find out what is the make, whether, and the things are like cost and the features. Okay, so once you decide, you can go and buy. For example, you can have a Logitech keyboard or probably a TVS keyboard, or nowadays whether you want to buy a mechanical keyboard which makes lot of noise, people are now more interested, or a very silent keyboard, like that. Even layout will be different. Layout is very, very important. So that's another and how many whether your mouse should be able to play the games with having not just 3 buttons, more than that. So all such features can be explored. So anyway, layout of the keyboard is also very important. Now comes the monitor, or which is also called the VDU. The first one is, there are lot of parameters to consider. Parameters like, for example, first one is make, because it's very important, because depending upon good monitors, for example Asus monitor or a Dell monitor or a HP monitor, so it will cost you varieties of prices. And what is the size? What is the size means whether you want to buy 21 inch or 23 or 24 sometimes, and then 27 and then 32, etc., or you want only the smaller one like 15 inch monitor. Now nobody will buy this 15 inch anyway. So this is the kind of then very important thing is the resolution. That means how many pixels it can actually display, whether it should be full HD or half HD or 4K monitor or any ordinary monitor, like that. So these are the, normally we go for full HD nowadays, and if you are having a high-end gaming monitor, then it can be 4K, like that. So of course the very, very important thing is the cost. So you can actually calculate the cost. Okay, these are the, so once you, there are some other parameters, I don't want to deal with all those technicalities of. Then comes very interesting part. So that is the system unit. When you deal with the system unit, you need to buy what is called as a cabinet with SMPS, switch mode power supply. A power, it comes with the power supply. Of course, varieties of cabinets will come. So there can be ATX, that means automatic shutdown. There can be some other kind of, but always you should see that what kind of motherboard you are buying. So, or sometimes it is also called as system board. Okay, so which is the very base PCB inside the cabinet, and over which you have to mount everything, every component. And the next important thing is what are you going to mount on this motherboard. So it is nothing but the CPU. So when it comes CPU, what is the speed, and then whether you want to go for Intel make or AMD, etc. Okay, these are the two important players in the market. So what is the speed? That means in gigahertz. So you need to note down, and then whether it's a single core and or a multi-core. That means how many CPUs will be there, multi-core. So whether there will be what is called as 4 CPUs or 8 CPUs built in, or it can be 12, like that, etc. So these are the things which really matter. So, and then what are the other important things? You need to buy the extra items that you are going to mount, like memory. What is that? Memory. So when you say memory, so the RAM, because RAM is always built in, RAM. So when you want to buy, how much memory, and then what make will cost your pocket. So very, very important. There are a lot of players you can explore using Google. And then the size is very important. You know that size is always measured in for example 8 GB or 16 GB or 32 GB, and then sometimes 64 GB, even 128 GB, like that. So these are the different things which you always then comes the storage, the secondary memory, which is called as secondary memory, storage, which is called as secondary memory. This you can have different kinds of storage. It can be HDD, which is called as magnetic memory, and sometimes SSD. Now there are different kinds of SSDs which are called as NVMe. So these are all NVMe will be costliest type of memory because it works so fast. You cannot compare with the HDD. So your file transfers will happen very quickly. So for normally content creators kind of things, so NVMe is always suggested, like that. So if you look at such a complex, I have not added so many things. If you go on creating different items, I mean adding different items, and get to know there will be a relationship. So whether you have motherboard will support the built-in graphics card or built-in GPU or external GPU or dedicated. This is called as dedicated GPU. So now you know that the CPUs are coming with AI built-in. What is that? Artificial intelligence built-in. So then if you buy AI built-in CPU, then probably your motherboard should support it, or system board should support it. These are the kind of things what we figure out with a mind map. So this is only a glimpse of mind map, how you can actually understand the complex scenario and figure out and build the relationship between each item, each node, and then have a different perspective of the subject matter in focus. I think we come to the end of the webinar. I thank you one and all for participating in this webinar on mind maps. And it is not just participating, this should be the day of reckoning, and you should always start mind mapping every kind of subject which you are interested, and you will see a dramatic change in your life, that you will never lose this approach in your lifetime. I hope this moment will be the change in your life in learning whatever you want. Thank you one and all, and I thank Prajwal for cooperating for this streaming of this webinar, and also I thank my teammates, everyone who contributed in discussion what to be done for this webinar, and everyone's input is of immense importance. in this event. So thank you and goodbye. And there are a lot of other for your kind information. There will be such free webinars and every weekend on Saturday, which is normally now we would like to call it as Klaritree Talks, and it will be free and every interesting topic in this technological era, digital technological era. So we will try to bring in and update you and refresh you with your knowledge. So please do participate and encourage others to come online and participate, because it's free. Probably if this input gives you a new awakening of your mind, I think my job is done. Thank you, one and all.